Hi, my name is Shadi. This is my 9HD submission. I hope it meets your expectations. Thank you.
Hi, my name is Shadi. I will be walking you through Task 9HD. I investigated 5-class cardiovascular ECG classification using 2 representation strategies: engineering physiological features from the signal, or learning directly from the raw waveform. The paper I selected was the 2023 study called DASMcC. It uses PTB-XL 12-lead ECG recordings and extracts 16 time domain feature families, 5 P, Q, R, S, and T locations, 5 matching amplitudes, and 6 intervals. SMOTE is then used for class balancing before 5 classical classifiers are compared. The paper reports XGBoost as the strongest model, at 93% accuracy. DASMcC sits in the interpretable, feature-engineered branch of ECG machine learning. That branch was still relevant in 2023, but raw waveform deep learning benchmarks on PTB-XL were already established before this paper, and the field has since moved further towards self-supervised ECG foundation models. So the paper is best understood as a lightweight classical alternative during a broader shift toward learned representations. I reproduced the study using PTB-XL version 1.0.1. A strict single-label cohort produced 16,272 ECGs, and the reconstructed PQRST representation contained 4,928 features per ECG. XGBoost was again the strongest reproduced model, but its untouched holdout accuracy was 73.09% rather than the published 93%. That gap raised an important forensic question. Can evaluation ordering change the apparent result? In the leakage-safe pipeline, the split happens first, and SMOTE is applied only to training data. In a deliberately risky sensitivity test, SMOTE is applied before the split, creating statistical dependence across the evaluation boundary and optimistic bias. This demonstrates a mechanism, but it does not show that the DASMcC authors used that ordering. I further tested removing the PQRST feature engineering entirely. Each ECG is used directly as a 12 by 1000 raw waveform and passed through the implemented 4-block 1-dimensional CNN class imbalance is handled with class-weighted cross-entropy instead of SMOTE. I also use the official PTB-XL patient-aware folds, 1 to 8 for training, 9 for validation, and 10 for the final test, with 0 patient overlap. Now shows the research in 4 clear steps. First, the reproduction comparison. The DASMcC paper reports 93% XGBoost accuracy. Our leakage-safe reproduction reaches 73.09%, while the patient-independent raw ECG CNN reaches 74.33%. This establishes the main reproduction gap. Second, the confusion matrix. The raw CNN correctly identifies 741 normal ECGs, 184 myocardial infarctions, 172 STTC cases, 24 hypertrophy cases, and 107 conduction disturbance cases. The key weakness is hypertrophy, where only 24 of 56 cases are correct. Third, the imbalance experiment. No SMOTE gives the best overall accuracy at 75.67%. SMOTE reaches 73.09%. Class weighting reaches 72.26%, but gives the best macro recall at 63.57% and raises hypertrophy recall from 23.36 to 42.99%. Finally, the 2026 context. ECG Lens reports 80% accuracy on PTB-XL, while a simplified CNN-VAE reports 87.01%. These protocols are not identical, So this is context rather than a strict leaderboard. The key insight is that substantially different pipelines still occupy a similar overall performance regime. That does not prove a fixed performance ceiling. Instead, it suggests that classifier choice alone is unlikely to explain the result. Cohort construction, physiological overlap between diagnostic classes, minority class scarcity, and the difficulty of the 5-class problem are also important. What I learned is that data construction, evaluation design, and imbalance treatment can be as important as the algorithm itself. I failed to completely isolate the reproduction gap reasons. In the controlled XGBoost reconstruction, SMOTE was not uniquely necessary for competitive performance. The next step will be to communicate with the paper authors to try to get the code used and identify the source of the 20% difference. Thank you.